starlight, star bright. The first star Webb will see is HD 84406. Well, it may not exactly rhyme, but the James Webb Space Telescope has its first target. A bright point like HD 84406, located in the Ursa Major constellation, provides a helpful target by which the team can calibrate mirrors and equipment. But what exactly will the James Webb Space Telescope enable scientists to learn about the universe? Fox 44's Gary Ainsworth spoke with a local cosmologist and has more on NASA's newest tech toy.
On Christmas Day of 2021, NASA launched its latest, most high-tech space telescope ever made into the heavens. The James Webb Space Telescope, referred to as JWST, is named after former Administrator James Webb, the man who led the space agency from its beginnings and the Apollo program. The JWST is a major upgrade from the Hubble Space Telescope, which recently celebrated its 30th birthday. While Hubble is located in a low Earth orbit, staying roughly 350 miles above Earth, the JWST will operate much farther away, reaching its final destination last week in one of what's known as Lagrange points.
These are 5 special points where a small mass object can orbit in a constant pattern with 2 much larger masses. And these specific points are the location where an object is in a fixed position with regard to the Earth-Sun system.
What this means is the JWST can maintain its position in space between the Sun and Earth because the pull of each one's gravity is essentially balanced, only requiring the JWST to make minor adjustments with thrusters periodically.
The Lagrange point chosen for the JWST is labeled L2. It's over 1 million miles from Earth, about 4 times further away from the Earth than our moon. Nevertheless, L2 is one of the 2 Lagrange points closest to the Earth.
This location, along with an enormous sun shield, allows the telescope to be oriented so its lenses and detectors are always facing away from the sun, blocking any interfering light, while also keeping the telescope at its best operating temperature, a cool negative 387 degrees Fahrenheit.
It will be able to observe objects such as the galaxies in the universe much more distant than ever before, while also able to focus on atmospheres of extrasolar planets. It can also study stellar nurseries shrouded in dust. Observing more distant galaxies that the JWST can do than Hubble translates into observing galaxies at much earlier times in the universe than ever before.
The location also allows for continuous and stable communication with the Earth's Deep Space Network ground stations, located in California, Spain, and Australia. Webb's optical telescope element is made up of 18 hexagonal gold-plated beryllium mirrors that reflect light into the primary lens. Now, the combined effort of reflective surface area of 21 feet in diameter is twice that of Hubble's, collecting roughly 6 times the amount of light. Webb will begin sending back images to Earth that astronomers and cosmologists have only theorized using equations and mathematics, virtually time traveling into history, seeing literal images 13 billion years into the past.
This will enable a broad range of investigations across the fields of astronomy and cosmology. Translates into objects that were formed, that first emitted the light over 13 billion years ago.
What does the telescope 1 million miles from Earth, seeing distant objects so far away that it's taken 13 billion years to reach Webb's lenses, mean for mankind?
It's important, I think, in understanding the origin of the universe, which relates to ultimately the development of sentient life as we know it now.
Like the man it's named after, the James Webb Space Telescope will lead NASA in its future discoveries by looking into the past and possibly reveal more than we've ever imagined.
I think we go through, in terms of the stage of knowledge in science, we've gone through a series of paradigm shifts, understanding the origin of the universe and of us.
Gary Ainsworth, Fox 44 News.